Hi friends, in this video let us learn about biasing of N-channel MOSFET transistor in enhancement mode. Right? So this is a circuit diagram and R1 and R2 are biasing resistor, RD is a drain resistance and this is the NMOS, that is drain terminal, gate terminal, source. Right? So what is the aim in this session? Aim to find VDS and ID. Right, these are all the two parameters we have to find from this. How we are going to find, let us see. So first what I am going to find is step 1, I am going to find VG. You will wonder why I am finding VG. You will get the answer very soon. So we know in MOSFET gate is insulated, so it won't allow any current. So IG is 0. So the current through this branch is 0. So whatever the current comes here, it will go here. So these two, the current is same for these two resistors, so the resistors are in series. So I am applying voltage divider rule to get the voltage across the gate terminal. This is VG. So VG is nothing but voltage across R2. So VG is, I apply voltage divider rule, total voltage into corresponding resistor divided by total resistance. So this is VG, right? Next, what is Vs? This is voltage 0, ground potential. This potential and this potential are in same point. So both are having the same potential. So Vs is equal to 0. So what I find is VGS. Why I find VGS, you will understand. VGS is nothing but VG minus Vs. Vs 0. So VGS equal to VG. That is equal to VDD into R2 divided by R1 plus R2. Next, what is my aim? My aim is ID, to find ID. So when mass in saturation, what is ID? ID is equal to Kn VGS minus VT square. So VGS, I want that VGS is here. So to find ID only, I found VGS. To find VGS, I need VG. So this is the procedure. So VGS I found. So ID is equal to Kn. These two are device parameters. Kn and Vt are device parameters. That is given in the problem. It will vary depending on the device. Next, what I have to do, my another aim is to find VDS. The voltage between source and drain, right? So this is VDS. So it is VDS. So I want to find this. So this is VDD. Here the current flows through a drain terminal ID. So it is drop is IDRD. So from VDD, if I subtract this value, I get what is VDS. So VDS is equal to VDD minus ID. So we found both the values. Fine. So this is a simple problem. Okay. So let us solve one problem from this area. Let us assume the mass is like this. Right here. So not given. So here it is like this. Okay, so it is NMOS. So as per the problem. So this is 30 kilo ohm. This is 1.5 kilo ohm. This is 20 kilo ohm. This is NMOS. This is 10 watt. So what we have to find? We have to find ID and VDS, right? So given Vt is equal to 1, right? Vt is equal to 1 volt and Kn is equal to 0.1 milliampere per volt square. So we have to find IT and VDS. So we know ID is equal to Kn VGS minus Vt squared with the assumption that mass in saturation. In this way, assume if it is not in saturation, we have to proceed in different way. So ID, VGS I need. VGS we know how to find. VGS equal to VG. That is given by total voltage and voltage across this 20K divided by total resistor 20 plus 30. So it is 4 volt. So I got VGS. Right. So ID is equal to Kn they have given 0.1 milliamps. VGS 4 VT1 square. So ID is equal to 0.9 milliamps. Next, what we have to find? We have to find VDS. VDS is equal to VDD. That is given in the problem. ID just now we found RD is in the problem. So substitute all the value. VDS is equal to 8.65 volt. And we have to confirm whether these values are correct or not. What is the assumption we made? We made device in saturation. For saturation, we know VDS must be greater than VGS minus VT. So VDS we found, what is that? 8.65 volt. VGS we found it is 4 volt. VT is 1 volt given here. So 8.65 is greater than 3. So our assumption is right. So this implies saturation. So ID is 0.9 is right. VDS is 8.65 is also right. So we start the problem with the assumption that the device is in saturation. Like that you proceed, and once you complete the problem, check the assumption is correct or not. If the assumption is correct, this is the final answer, right? Our assumption is correct because for saturation VDS must be greater than VGS minus VT. So assumption is fulfilled, so the answer is correct. Thank you.